Good morning. All right. So for today, we're going to focus on more linear equations. Sorry, I have no coffee yet. But instead of looking at a graph and a table or points, we're going to look at word problems and correlate all the same information. So I got three different questions I'm going to go through, okay, just so you have all this different modeling for you to help you guys out today. And I'm going to answer three basic questions. I'll be changing these up as I go through each question. First one is a taxi cab charges $2.50 when you enter the cab and another $1.50 per mile. The second one is a plumber charges $50 for showing up and then $35 per hour. And the last one is Ella gets a $30 phone card and is charged 50 cents per minute for calls. I bet you're all thinking, what the heck is a phone card? Because your generation has no clue what a phone card is. So I'm going to show you what's going on. All right, I'm going to answer this question first. I'm going to go through, so take notes and make sure you ask questions in today's class. A taxi cab charges $2.50 when you enter the cab and another $1.50 per mile. So first thing we're going to do is set up an equation to model each situation. Now, I'm going to say this time and again, time and again, time and again. Please make sure you always have a key for your variables. You can use whatever letter you want. You can use X and Y every time, or T and M in this case. Doesn't make a difference. So first thing you're going to do is, what are your variables? T for total charge. Okay, and we'll say this is, our variable is miles. And we'll say M for number of miles. So that's the first thing. Well, my total charge is changing by you can do it like this. You could either write down 250 plus a $1.50 M, or you could have done this. T equals a $1.50 M plus 250. That's a little dot right there. Now, I am a creature of habit, and I always like to put my rate of change or my slope in the beginning and my y-intercept or my initial cost at the end, because that's how we typically see it. So I like this, but if you like this, either or is totally fine with me. How much does it cost for 13 miles? Well, go in your equation you built and replace M with 13. So you got a $1.50 times 13 plus 250. So a $1.50 times 13, let's see, a $1.50 times 13 is $19.50. So T equals $19.50 plus $2.50. So your total cost is $22. Okay? That's as easy as it is. Just take your time, replace the variable that we're given, solve for the variable that we don't know. If the customer was charged $35.50, can we all see this? How many miles did he go? So now we know the T because we were charged $35.50. So $35.50 equals, write down the rest of the equation that we did not use and start solving by using inverse operations. Okay, $35.50 minus $2.50 is 33 even. Divide both sides by a $1.50. And your number of miles ridden for this charge is, let's see, 33 divided by a $1.50 is exactly 22 miles. That is the kind of work you're going to be doing today. Writing down, take detailed notes. So that's that. Pause this, write down anything you might have or don't have, or just catch up. I'm going to go on to the next question right now. So, I'm going to change some of this around a little bit just to make this efficient. This question stays the same. And I'm changing this to 4.5 hours. This is for 4.5 hours. And this one is for a charge of bear with me, for a charge of 408 customer was charged $408.75. How long was the plumber there? All right, now the next question says a plumber charged $50 for showing up, then $35 per hour. Let's see if we can all see this. $35 per hour. All right, first thing we do is set up that equation to model the situation. So again, we're going to use T for total charge, and we're using hours, so we'll say H for number of hours. Okay, you can still use Y and X, I'm just choosing to use these two variables. So my total is T equals, I'm a creature of habit as we all know, 35H plus my initial fee for showing up, or the plumber's initial fee for showing up. There you go, that's the equation. How much does it cost for 4.5 hours? So we can just go in and we can replace H with 4.5. T equals 35 times 4.5 plus 50. So when we do this math, it's going to come out to T equals 157.550 plus 50, and my total charge is $207.50. Plumbers are expensive. Ask your parents, they'll tell you. Well, the good ones are, at least. There you go. That's that. And the next question says if the customer was charged $408.75, how long was the plumber there? So again, what letter do we know? We know T. That's the total charge. So write down, replace what letter we know. 408.75 is equal to 35H plus 50. We can all see this, I'm hoping. And now let's just solve by using inverse operations. So I'm left with 35H over here, and I'm left with $358.75. Last but not least, divide both sides by 35. So we get our number of hours this guy was there was exactly 10 hours and 15 minutes, 10.25, okay? That is that. That takes care of that example. And my next example is going to look a little different, so make sure you pay close attention to what's going on. So that is everything. Let me rewrite some of these questions a little bit. The first one stays the same. We're always going to write the equation and model the situation. Let's say for 30, how much does it cost for 35 minutes? 35 minutes. Try right now, I'm writing this. Try to come up with your own equation for this situation because it's not as straightforward as it looks. Customer, if how many minutes can Ellie use it before she runs out of time? Now, I purposely chose this question because I am pretty sure your generation has no clue what a phone card is, because you probably never used a payphone or called collect or whatever it may be. But this is a good question because it has some relevance and other stuff we're going to do later. But Ella gets a $30 phone card and is charged 50 cents per minute for phone calls. Let's set up an equation to model this situation. So we got our T for total money left. So now remember, there's total money. This is where we comprehend the question. Total money left. And we're going to say M is our number of minutes. Now pay attention. I'm being explicit in identifying exactly what each variable means because that just shows a deeper level of comprehension and it makes some of the stuff we're going to do later a little easier. please make sure you're doing this and you're not calling this minutes and money, because you'll see why. Ella gets a $30 phone card and is charged 50 cents per minute for calls. So it's like you're given money, and every time you're in the phone call, a little bit of that money gets chipped away, gets chipped away, gets chipped away. So our T is going to equal, pay close attention, 0.50x minus 30. Because we're always taking money away from that $30 initial phone card. How much does it cost for 35 minutes? I'm sorry, I should rewrite this question. How much is left on the card for after 35 minutes? I should say after. So let's see. So T equals 0.50 times 35 minus 30. Well, 35, sorry, minus 35, times 35 minus 30. So our T is going to equal 17.5 minus 30. So the total amount left on the card after L is on the phone for 35 minutes is $12.50. Now this question right here says, how many minutes can Ellie use it before she runs out of time? I should have said on the card. Before she runs out of money. So total money left, runs out of money, the lowest you can go is 0. So let's see what this entire thing is worth. If this is 0, I replace T with 0, and I'm going to do 0.50, we're calling it M, minus 30. I'm going to add 30 to both sides this time. That's why you got to be careful, because negative positives have a big difference. Divide by 0.50, M equals 60. This is what the majority of your stuff looks like today, as well as the stuff we've been working on for the past couple days with slope, tables, graphs, and I'll answer those questions during whole group today. But I will see you all in class.